What's up, YouTube? In this video, we will continue on with our previous videos, code review, and I've got just a few things to finish off from the previous one. We'll be talking about code review issues with regards to async and await, as well as the iDisposable pattern. Now, I would potentially talk about the iDisposable pattern in my video on GC, sort of like a deep dive, if you will, on the GC side, which I've not done yet, but I do plan to do that. In this video, the iDispose will be just like a surface level thing, just enough information for you to see, detect, and know how to fix. And for this matter, the same thing goes with the async await one. There is a full out 2-part video on async await. This is more about the code review thing. So I'm going to be talking about some things or issues with async and await that you need to watch out for, but I may not explain all the details for the why and the what. All right, so let's get started. Okay, so in the previous episode, we kind of left it off here where we had refactored this code here into a method. It was originally over here, and we then extracted it to this method called getMoviesForCombinedTasks, which takes a bunch of tasks, and then this method is marked with the async modifier. It has an await here, but it has to unwrap the tasks, and then once it's unwrapped the tasks, it gets the movies from the result and then concatenates, if you will, one list into or two lists into one list and returns that, right? And as usual, we have a configure await false here for every call that has an await. This is not by default. It just depends on the code you write, by the way, whether you can or should use the configure await false. Ideally, you should want to be able to use configure await false, but that may not be possible depending on the way you write your code. Essentially, if it's stateful code, it becomes almost impossible to use the configure await false, at least without having issues, and these issues will be intermittent or sometimes, and you may not be able to reproduce them, and so you might get those kind of issues. But in my code, since I don't actually use state, I'm able to do that without even thinking about it. All right, so now, here's the first problem. So before I even start with async await, I'm going to use some terms. I'm going to explain or demonstrate to you what those terms mean, and then I'll explain the problem. All right, because that way at least you'll understand why I'm saying what you should or should not do with regards to async await. Rather than returning this here, I'm just going to assign this to a variable. So let's just call it for now temp. All right. Now, what do you think temp is? Got it? Okay, I'll show you. So temp, in this case, is an IEnumerable of some t, and the t in this case is a movie. So temp is an IEnumerable of movie. All right. What if we don't await it? So I need to take this out as well. What is it now? Well, let's find out. So if we look at it now, oops, sometimes it gets faded before I can zoom in. Now it is a task of some t, and t is an IEnumerable of movie. So just to recap, when we had the await on this method, or await, we were awaiting this method, the returned thing was a task of some t. Sorry, was an IEnumerable in this case of movie. When we don't await it, we get a task of some t, and the t is an IEnumerable of movie. All right? Okay. If that makes sense, then when we use an await here, we frequently say that we unwrap the task. Remember, without the await, we were getting a task of some t result. With the await in place, we were getting the IEnumerable of movie without the task. So we unwrapped the task, as in we removed or extracted the task when we do an await. All right? Okay. This method's signature says it requires you to be returning a task of IEnumerable of movie. You confused yet? Are you getting where I'm going? Okay, let's hold on and watch this now. Without the await, we are getting an task of IEnumerable of movie. So you would think, well, then we should be returning this, right? Since that is what we are getting here. The return value type of this method is an task of IEnumerable of movie, and that's what this method is returning. It's returning a task of IEnumerable of movie. But the compiler is not going to like that. It's going to say something like, well, let's just read it out here. It says, since there is an async method, since this is an async method, the return expression must be of type IEnumerable of movie rather than a task of. All right, so when a method is marked with the async modifier, you are not effectively returning a task of that thing, the t. So when this method is marked with the async modifier, you're really returning the t result and not the task of t result when it's marked with the async modifier, right? Okay, therefore, over here we had, going back to the code the way it was before we even started mucking about with this minus the configure await here. So that's what we had when we started. This was the code, and you're doing a code review here. So what are you watching out for? I'll try and keep it simple, or try and give you a way to recognize the problem, all right? Is this method here, is this method using the awaited thing? Is this method, the method that we're working with here right now, which is marked with the async modifier, and it has at least one await in the method, which is fine. But is this method itself using the awaited thing? That's what you want to look for. In this particular case, this method is not using it. It's simply returning it. If you look here, this method has got an await here, and it's got an await here. Is this method using the awaited thing? Yes, it does. It's not obvious, but when the task.whenAll is awaited, execution comes to this line after both tasks have finished or completed. And then we do get the result of that. So we are using the result, which is the case, the movies in this case. So we are using the awaited thing in this method. In this method, we are not. All right. So if you find in a method that what you are awaiting is not being used by this method, that method is simply returning it, you should not await it. Now, of course, there could be issues with what I'm saying here in the sense that what if, for example, here I need the await, and over here I'm not awaiting it. So yes, you can, if you're just returning something, you're saying return await something, you don't need that last await. But in this particular case, there are no other awaits. So if I would remove this await here and return that, then the compiler is going to, let me also just remove this. The compiler is going to complain like we saw before. You know, it's saying, since this method is asynchronous, blah, 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 you have to return a task of something. So you need to return an IEnumerable of something, but not a task of something. We know this is returning a task of something. We don't want to await this because we are not actually using the awaited thing. We are simply returning it. The solution is to remove this async modifier here. Now this is perfect code. Nothing wrong with this. You immediately must be thinking that what happens to the call site? Because the call site was expecting this method to be an asynchronous method. Well, let's look at the call site. The call site, so the references to this method here. Oops, I'm still in. Are in this case, the domain facade. So if I go in here, well, look at that. This method also is not, it is awaiting, but it's not using the result. It's simply returning it back to the caller of its caller. So we should probably be removing this, but it's not affected really. There's no change yet. There's no squiggles here to say something is wrong. And that's the point. The point is the async modifier is not affecting the signature of the method. The async modifier is not a part of the signature. So as far as the call sites are concerned, when you remove the async modifier from a method like we did in this case here, in the movie manager, we remove the async modifier from this method, and we remove the await from this method. The callers are not impacted by that. Why would you want to remove the async modifier and the await in this case? Every method that's marked with the async modifier has an overhead. At compile time, our code with every method that's marked with the async modifier gets a whole ton of code associated to this method that the compiler generates, relatively the state machine, but it's a fairly large bit of code, and it's also allocating a bunch of memory with regards to additional objects. Every method that's marked with the async modifier gets that extra code. So it grows your working set, as your runtime memory, if you will, your application is running. A bunch of allocations, that means they have to be deallocated, that's going to cost you, and so on. The cost can be amortized when you're doing IO-bound workloads, which is when async await should be used. But that doesn't mean you want to have an unnecessary number of async methods, right? And that's the part of the code review. In code reviews, you're not looking at just guidelines and coding conventions and all this sort of code reviews are way beyond that. I expect typically my team, I don't expect coding guidelines and conventions and those kinds of issues. I'm looking for these kinds of issues. I'm looking for stuff that can go missing as you're developing. You may not have that keen eye for sort of the optimizations and the cleanups because you're writing the code at this point. I'm looking for those things. Where can things be going wrong? Where are things incorrect? Where can you get more performance or optimizations or less memory utilization, things of that nature, exceptions. Hopefully, the code review should go beyond the standard, coding conventions and naming conventions and guidelines and that sort of thing. The true value of code reviews comes from making sure the code is maintainable and, of course, readable by extension, and also doesn't have issues, potential issues. Maybe it's multi-threading issues. Maybe it's disposables and garbage collections and memory allocations. Maybe it's async await. Maybe it's exceptions, that sort of thing, right? So I'm going to go back to the references for this one and go back to where we came from, which is our domain facade. I'm saying here now, even though this method is marked with async modifier and is awaiting the return of this method here, this is the method we were in before. We need to take out the await here because we are not using the result here. That means this method also does not need to be marked with the async modifier. So two methods have been removed from having the async modifier. You can't have the configure await here either. Okay, let's look at this one. This method's call site. And that is the controller. Okay, same thing here. This method is awaiting, but it's not actually using the result. So we can take out this await. We can take out the async. And we can, we can't have the configure await. Let's go to this method's call site. And okay, so finally, this is the method. This is the entry point of the system, the controller that okay has to extract the movies or get at the movies. So it has to await the task and then convert those movies to a JSON and return that out to the caller from the browser side or whatever. So we had a controller from your side. There's the input, that's the controller, data coming from here. And then down in the guts of our system, we had our data layer that went and got, let's say, the data from our database. And so it required that async capability because we are opening connections and making network calls across to the database and the gateway as well, and some external service. That's IO bound, so we were doing asynchronous work there. But literally throughout the entire call chain, there was no real need for all the entire call chain to be asynchronous. It is asynchronous, but they're not awaiting, right? So the result that came from the database, say, is passed back here, and finally the controller needs to extract that data out and do something with it, conceptually. So the await here is fine, of course, because it does need to get to the movies, or get at the movies, and then it needs to map the movies to a resource model and return them, and it gets converted to JSON. So when you're looking at code or doing code reviews for async, you're paying attention to these kinds of things. Do we need to have this asynchronous? Is something that is IO bound not being used asynchronously? Maybe it should, like we did before. The method here that we did the map to movies, this was doing a database data reader.read, but it was not async. So we need to look at that. Okay, is this potentially an IO bound workload? If it is, it should have been done asynchronously. Why is it not being done? So that was the one issue here in the very first code review I think we did. And then in the last one, this one, we are looking at saying, well, if a method is doing the async and await, is it actually using the result? If it's not using the result, why the heck do we need an await? And potentially you can remove the async modifier from the method because potentially that's the only method that was doing an await in the first place. If the method is continuing to do awaits, you can't actually remove the async modifier but you can. And as a result, you have to await it, because if you remember that whole thing with the unwrapping the task thing, that's your indicator, right? If the method is marked with the async modifier, it says you can't send me you can't return a task of something, you need to return the something. But if the method is not marked with the async modifier, you are effectively returning a task of something, and then if you await it, you're unwrapping the task, so you can't do that. So for example, in this method here, this method, if we're doing an await here, we're returning movies here, there's no await here. But if we had an await here at the end, for whatever reason, for the reason, let's say there was something asynchronous going on here, then we would not have been able to remove the await this method, because this method needs to remain marked with the async modifier. And here, if we did not unwrap the task by awaiting it, then it won't work, because the method, when it's marked with an async modifier, cannot be returning a task of t, you need to be returning the t. When the method is not marked with the async modifier, then the method can be returning a task of t, and you can actually return a task of t like we're doing here. This is a task of t being returned. All right? Hope that's not too confusing. All right. Now the next part is the iDisposable. There are some patterns to the iDisposable. There are some good representations of the pattern, bad representations of the pattern, including on Microsoft's website, including on some of the books. What is one of the books I have? I forget the name of the book. They talk about it. They give you the recommended pattern. Some of them are outdated. So I'm going to tell you what you should be doing, when you should be doing it high level from a code review standpoint. Okay, so for that, we're going to go look at our gateway. Oh, there it is. So I have a gateway here. I'm just going to give you a high level brief overview of this code so you understand what's going on, and then we're going to look at the iDisposable. Of course, it implements the iDisposable. It's essentially using an HTTP client, which is a .NET Framework class, but that class is an iDisposable. The HTTP client is internally using sockets. Sockets are unmanaged resources. These are operating system resources. They're not in the .NET world. The HTTP socket is in itself a managed resource, but it is internally using an unmanaged resource. So therefore, it is iDisposable. If you're using a class that's iDisposable, then you should also you should also dispose those classes. That's what this gateway is going to attempt to do. Since it's using the HTTP client, we know it's an iDisposable. The HTTP client is, therefore this gateway needs to be disposing it. But that means the caller of this gateway needs to be disposing the gateway, and so on. So this is I say iDisposable is like a virus. Once you have it somewhere, it goes all the way up the call chain. So because the HTTP client is iDisposable, this gateway is implementing iDisposable as well, so that the caller of the consumer of the gateway can dispose the gateway, which in turn can dispose this HTTP client. So you can see how it kind of goes up the call chain. All right. Now, I'm just going to show you the dispose method here. Oh, of course, there's also, sorry. So there's a disposed bool, and this is part of the pattern, the recommended pattern. So I've declared a member called disposed, which is a private member, and this HTTP client, and I'm going to show you how it's been implemented here. The iDisposable interface has only one method on it called dispose, which is here. And the recommended pattern is this. You got to implement this method, of course, but the way you implement it is like this. It's in turn calling another method called dispose with an argument, the bool argument, and in this case, you're calling it with a true, and this is the other method. In this method, you get the disposing argument, and you see, well, if we're disposing, as in come from the dispose method here. So if we're disposing and has not been disposed, which is the other private member I showed you earlier. So if these two conditions are true, you can do what you need to do here to dispose of any classes that you are using that are disposable. Remember, the gateway is not working directly with an unmanaged resource. It's working with an HTTP client. There's a distinction here. That's why I'm calling it out. The HTTP client internally is working with an unmanaged resource. But we are not. We are working with a managed resource, which is an iDisposable. Okay. So if we had 2-3 things to dispose of, we would do it over here. The typical pattern I've seen is this. If this HTTP client is not null, then dispose it. Of course, you are being safe. What if it is null? You can't just dispose something. It will blow out with another reference exception. So you do this. And then you say dispose equals true. So that the next time when this method is called, you don't come in this again and again. You just do it once. That's the idea. That's the basic idea. That's as per the recommended pattern. But there are problems here. There are a few problems here. And that's the point of this code review thing. How do you know there's a problem and what should we be looking for? Number one, I'm going to keep it high level. We'll probably talk more about this gc.suppress finalize when I talk about my, in my video, my garbage collection video where we talk about the finalizable queue and the f-reachable queues and stuff like that. I'm not going to be talking about here, but I'll give you the way to recognize the problem. If the class, in this case, our gateway, is not directly working with an unmanaged resource like a socket or a file. I'm talking about the unmanaged resource, not the .NET file class, but what the .NET file class might internally be using. If a class is directly working with an unmanaged resource, it should be calling gc.suppress finalize this. There's a whole other story, but just keep it in mind that way. If the class is not, the class in question, is not directly working with unmanaged resources, it should not be calling gc.suppress finalize. Now, if it does, there's no harm, but there's no value. Programming with intent, you should show me your intent. And as a result, you should take this out. In this case, we are not directly working with an unmanaged resource, so there's no need for the gc.suppress finalize this. So that can be taken out. Now let's look here. They're saying if it's disposing, and it's not been disposed, and if HTTP client is not null, then dispose. Now, given the way this class has been implemented, the HTTP client can be null when the dispose method is called. All right. So the need to check if HTTP client is not null and then call the dispose is correct. But let's look at the code. So if it's, let's say it's not null the first time around, so therefore it calls dispose. Then you say dispose is equal to true, and you come back out. Now, what might happen is that some, what do they call, linters, like sonar lint and a bunch of other things like that might warn you about an issue. You're saying, hey, you know what? This thing can actually just be put on one line. They can all be in one. Okay. This will be a recommendation from linters, as I said. And so, typically we follow these linters. Bad idea. I'm not saying you shouldn't, but don't blindly follow what the linters are saying. You need to understand for yourself. Is it understanding what you're trying to do? Let's look at the problem now. I'm just going to cut short and say that this HTTP client may be null, not null. This HTTP client may not be null the first time. But if you never set it to null, that's a problem, because if you're going to check against it being null or not being null and then decide whether you should dispose or not, then when do you ever set it to null? Right? So no matter what your condition ends up being, whether it's like this or like that, and all I'm trying to get across is that your system is going to get modified as time goes on. Things might be added. You need to write the code correctly so that the next person that comes along also continues with your pattern, and then it may actually be relevant. Right now, it may not be relevant, what I'm showing you, but it may actually be relevant eventually. So rather than have to completely contort your code later, write the code correctly this time so that the next time somebody comes, they just copy and do the same thing. And the correct way to do this really is you do this. You say if the HTTP client is not null, right? Then you want to do all these things. However, due to multi-threaded issues and a bunch of other scenarios, what you should really do is you declare a local variable. So let's call it local HTTP client and assign it to the member, private member, right? And then you can dispose of the local member oops, what is that? Local, oops. And then you null out the actual HTTP client, because you're checking against it, then you should be assigning it to a null at some point in your system. Now this is a read-only member, so it's not going to let me do that. So I need to take this out here. Okay. All right. So I'm guessing now it's telling me that. See, merge this if statement with the enclosing one. I'm not saying you shouldn't. So this is also a mistake here. Yeah. I'm not saying you shouldn't, but I'm really talking about is this part here. Checking against something that is null may not be valid because you're never setting it to null. Now, maybe null originally, right? But what if it was initialized and now you're checking to see if it's null, and you say, well, if it's not null, dispose it. Well, the next time also it's not null. Null and dispose are not the same thing. Dispose is essentially where the class is being marked for cleanup as far as the GC is concerned. It's indeterministic. You don't know when exactly it's going to happen. It's not going to happen now. It could happen 2 hours later. Really, 2 hours later. It just depends on what's going on in your system. If the GC feels the pressure, as in you're doing a lot of allocations, it might frequently, it's going to start frequently disposing and garbage collecting. But if it's not feeling the pressure, it's not going to do it right away. It could take literally 2 hours before it actually does that. Dispose is non-deterministic. Null is essentially saying this variable that happens to be pointing to some location in memory is no longer pointing to that location in memory. The location in memory has not been disposed of or cleaned up. Just this pointer, this reference is not pointing to that location. That's what null is. So dispose and null are two different things, and you can't consider them to be the same. So if you're checking against not null, then at some point when that condition is true, as in it's not null, then you should be setting it to null. Now you could directly set this HTTP client reference, call dispose, and then set it to null. But the recommended practice is declare a local variable because it's local. And so if something else happens to this member by another thread, this local member it's still got the reference to that location. In other words, you might have a private member pointing to this location and a local member pointing to this location, and something else comes, some other thread comes and wipes this pointer out, meaning nulls it out. You still have your reference to that place. So you can still dispose, right? That's the reason of doing this like this. So that's the correct way to do the dispose. Don't need the gc.suppress finalize this unless your class is directly using a unmanaged resource. If you're using something like an HTTP client or the .NET file class or a network socket class in .NET, you are not directly using unmanaged resources. So you don't need to use the gc.suppress finalize this. There's no harm using it, but what's the point? It's not like you can be safe about it. If you're never going to use it, you're never going to use it. So why unnecessarily add code when it's not required? All right. And so you would have this sort of implementation throughout the call chain, right, for the disposable thing. Anyway, I hope you liked this video. I hope you learned a few things, and I will see you next time.